So today we will be talking about exponential and logarithmic equations. As we know, the one-to-one equation is when the bases are same. So if the bases are same, it will happen only if and only if x is equal to y. Or on the other hand, if the bases are same, I don't need the basis, x will be equal to y. Same with the log function. The inverse function, it says if a and to the power is log a, both of them, they are same, I don't need them, it is just x. And the same thing will go with the log function. So these two properties, one-to-one property and inverse property, they are very, very important. Let's understand with the example. So I can write 9 to the power of x as 3 to the power of 2x, and 1/3 can be written as 3 to the power of -1. We have the bases are same, so this implies I can put the exponents equal to each other. So 2x will be equal to -1, and that will give you x is equal to -1/2. Let's apply the property with another example. So we have log with base 6. I need to get rid of log base 6. How? If I take 6 on both sides. And when you take 6 on both sides, log base 6 will become the exponent. 3 will become the exponent. So we are using the inverse property. So 6 to the power of log base 6 x is equal to 6 to the power of 3. So everything will jump up as the exponent. So the main idea is to make the bases same. Now, using the inverse property, 6 and log 6, both of them, they have the same basis. I don't need them. I can just say x is equal to 6 to the power of 3. And from there, you can simplify it. So these properties of one-to-one and inverse, you can use it in many different ways. Let's take another example. So in this video, we will just talk about bunch load of examples because many questions, they are written in a different way. So in this particular one, we have e to the power of -x² and then e to the power of -3x minus 4. So both of them, they have the same basis, right? But to deal with it, we will write -x² is equal to -3x minus 4, and this will give you a lovely quadratic. x² minus 3x plus minus 4 is equal to 0. Factor it out. You will get x plus 1 and x minus 4 is equal to 0. So that gives you x is equal to -1 and x is equal to 4 as the two answers. Let's take another example. Now we have 2 times 5 to the power of x and 32. So 2 is multiplied with 5 to the power of x. Let's divide both sides by 2 first. Isolate 5 to the power of x. Now at this point, we have 5 to the power of x is equal to 16. I can take log both sides because I need to bring x down. So if I take log both sides, log with base 5, so it will be log with base 5, we have 5 to the power of x is equal to log 16. Now on the left hand side, we have the base 5 and the number is also 5. So it will help us to isolate x. So x is equal to log base 5 and we are talking about 16. Now at this point, you can leave the answer as it is, or you can use the concept of change of base. So if you do change of base, we have discussed about change of base in the previous video. So it will become ln of 16 divided by ln of 5, and then you can just plug it in the calculator and you will get the answer. So in this case, we did change of base for natural logs. Right, and after this, just put ln of 16 divided by ln of 5 in the calculator and you will get the finite answer. So after this, let's take another example. Now it says solve e to the power of x minus 7 is equal to 23. So first isolate e to the power of x. So take 7 on the other side. That will give you e to the power of x is equal to 30. How to get rid of e? Take ln both sides. Because ln and e, they are inverses of each other. Ln of 30. Now x will come down. X is equal to ln of 30. And then you can just put it in the calculator. Let's take one more example. You have 6 times 2 to the power of t plus 5 plus 4 is equal to 11. So first thing first, take 4 on the left hand side by subtracting 4 both sides. Now divide both sides by 6. Now at this point, I need to bring t plus 5 down. How? Can I take log with base 2 both sides? Right? So that will help us. Log base 2 and write the whole entire number is equal to log base 2 7/6. Now on the left hand side, we can easily bring t plus 5 down. And that will be log base 2 7/6. At this point, you can use change of base and subtract 5 both sides. 6 then minus 5. And then we can use change of base. So if I change the base, it will be ln of 7/6 divided by ln of 2 minus 5. And then use your calculator. You will get the final answer. With this, let's take one more example. E to the power of 2x minus 7 e to the power of x plus 12 is equal to 0. I can make it as a quadratic. So consider e to the power of x as just the variable. So we can say let e to the power of x is just simply x, right? And with that, you can solve it as a quadratic, and then we will substitute e to the power of x back. So it will be x squared minus 7x plus 12 is equal to 0. Now it is easier for you to factor the quadratic. So this will give us at this point, we can replace x with e to the power of x. So we will get e to the power of x is equal to 4 and e to the power of x is equal to 3. Now we are not done yet because we need the value of x. So we can take ln both sides. Ln of e to the power of x is equal to ln of 4. And then ln of e to the power of x is equal to ln of 3. So x is equal to ln of 4 and x is equal to ln of 3. Right? So there are different ways to solve the equations involving the exponential and log. So every question is different. So you need to apply different techniques. So put it in the calculator and then try to put it in the calculator and you will get the value of x. You can try to graph it and see how the graph looks like. Now let's solve a few more problems. So ln of x is equal to 2. So to get rid of ln, I will take e. So whenever you take e, ln will work as the exponent. So it will jump up and it will become the exponent. So e to the power of ln of x is equal to e to the power of 2. So now e and ln will cancel out and we can bring x down. So x is equal to e squared. Let's have one more problem. And you can try. You can pause the video, try it on your own. The another problem that I really want you to try is 7 plus 3 ln x plus 5. So use any technique that you think would be easier to solve these two and give it a try. Let's try one more example. So if we have 3 log with base 4, 6x is equal to 9. So I need to isolate log. So first thing first, divide both sides by 3. Now we need to get rid of log from here, right? So what we can do, we can take 4 both sides and log will jump up. We are using the property of inverse. Now 4 and log base 4, they are same. So 6x can come down and we have 4 to the power of 3. That will give you x is equal to 16. Try this question and check for extraneous solution. When we talk about the extraneous implies that even though the solution is there, but when you plug it back, it will not give you the finite answer. So after this, let's try one application problem. So let's say the investment is of $500 with the annual interest annual investment rate of 5.25%, and we want you to compound it continuously. We have discussed about compounding continuously previously as well. So when we talk about compounding continuously, they are asking when it will double. That means when the amount will double. So initial investment is 500. So when the amount will be 1000. So compounded continuously implies that we are using the concept of PERT. So A is equal to P times E to the power of RT. Double implies that the amount will be 2 times P, which is nothing but 1000. So let's put everything back in the equation. We know R, we know P, and we also know what is A. So 1000 is equal to 500 times e to the power of 0.0525 times t, because we don't know t yet. So before we plug it in the calculator, we can divide both sides by 500. That will be 2 is equal to e to the power of 0.0525 to the power of t. And then I need to bring t down. So we will take ln both sides to get rid of e. That will give you ln of t is equal to 0.0525 t. And then we can divide both sides by 0.0525 and we are ready to plug it in the calculator. So plug it in the calculator and you will get number of years it will take for the initial investment to double. So these are the few examples that you can see for this topic. Keep on practicing these questions again and again, and you can pause the video and refer back to the properties again, and I will see you in the next video. Thank you for your time.